Hello, my name is Jackie Beltran, and I'm giving you a video or submitting a video describing, or not describing, but showing my knowledge of Kinematics, or the intro of Kinematics. First, before we start, up here is our north, up or positive, east, right, positive, south, down, negative, west, left, negative. These are different ways that will be listed in problems that will be given to you. This duct tape that I put on my desk right here represents the road. This point here to here is home and school. I have this little Hot Wheels. It is representing me or the vehicle. Then I have a ruler. For every inch is equal to a mile. Okay, before understanding the basics of kinematics, you must know that magnitude is the amount without direction. And displacement is the straight line between initial and final, which means this will be our initial and this will be our final. So it will be from here to here, drawing a line. Okay. We'll get back to displacement. But speed's formula is speed is equal to distance divided by time. And it does have magnitude. Again, magnitude is the amount without direction. So it does not have direction. Not the velocity without direction. We'll get into velocity later. So, basically, how this would work is, say right here and here is 27 miles. Depending on the time, you divide it. So let's say 27 miles divided by 3. We'll just say that. That would be equal to 9. Your speed would equal to 9. Okay. Velocity has magnitude and direction. Direction is basically your north, east, south, and west. Okay, so how that would look like is we said it was like 27, right? So 27 miles per hour. We're going west. Okay, that would be your answer if it was asking for the same scenario, getting from home to school. Okay. Acceleration has magnitude and direction. It's basically the same thing, except acceleration is whether an object speeds up. If this gets faster here, slows down a turn, faster, slows down a turn, basically the same throughout the road. Acceleration is either it speeds up or it slows down. Distance does not have direction. So, what I mean by this is we were to measure each piece of road, there's two ways to calculate this. You'll get questions like, if Barry ran 2 miles west, okay, if Barry runs 2 miles west, then runs 1 mile north, what was his distance? Well, basically what you would do is add them. 2 plus 1 is equal to 3. Common sense. Okay. But there's another way. If you're given the speed and the time, what you have to do is multiply speed and time, so you can grab your distance. Those are two different ways. And a very good example would be he's running at 5 miles per hour, and right, running 5 miles per hour, and then he runs those 5 miles within 2 hours, right? So what you would do, you multiply them, and that will give you 10. All right. So your distance will just be 10 hours. Or, sorry, 10 miles. Right? Okay. Now, we're going to go into there's something that you have to keep in mind. Distance is not equal to displacement. Displacement is from point A to point B. Another way you will see this would actually be, another way you'll see displacement, I forgot to add, is this your point A, you run, say, 10 miles to, I don't know, school. Then you run back 5. I'll leave you this point A to point B. It'll be your this is your final, this is your initial, or yes, so this will be your final, this will be your initial. Whoa. Can you see that? Let me fix this real quick. Kind of fell. Okay. Alright. So basically B, 5 minus 10 will be negative 5. Or just 5. This one is kind of, I'm not sure about, which I need to do my homework on. Okay. Another thing to know is velocity is not speed. Velocity, magnitude, and direction. Speed only has magnitude. Okay. Now let's talk about where are they? Now let's talk about the formulas. Okay, so let's start off with the easy one. Speed. Speed is equal to distance divided by time. You see that? I don't know if you can see that. I'm gonna pull that up. Speed is equal to distance divided by time. Velocity is equal to delta x divided by delta t. And what we should say is change in position divided by change in time. And the way you calculate that is position final minus position equal initial divided by delta t. What's it called? I'm sorry, change in time. Okay. Other one, displacement. Delta x is equal to position final and position minus position initial. Change in position. Should always remember that. The last one I'm going to cover is acceleration. Acceleration is equal to change of velocity divided by change in time, which is also equal to change of